times 10 to the power 3 millimeter 4, or 3.88 times 10 to the power minus 9 meters 4. Okay, so that is my. So the next thing we're going to find, so we found our IZZ. Just to recap where we are, we found our IZZ. Okay, we found our PX. We also can find our area. Okay, so area. All right, area in fact we have found already. So area is equal to 104. Right, times 10 to the power minus 6 meters squared. I got it from here. Okay, so this is millimeter squared. Okay, change to meter squared. So that is our IZZ. Okay, so the next thing that we want to find is with. So
Don't
now
you have to add the top section, sir?
Huh?
Don't you have to add the top section for the area?
Yeah, I did. 104. 40 plus 64.
Oh, yeah. Okay, sorry.
Oh, you gave me a jump down there. Okay, I had a fright. So now we also can find our MZ. Our MZ, if we were to recap, our MZ is equal to what? So we are going to use this formula. Okay, we're going to use this formula. Right? So that's why I say taking data from the top is so easy, right? So PZ, MZ is equal to 400 multiplied by 50 times 10 to the power minus 3 plus by 8.154 times 10 to the power minus 3. Right? So this will be equal to 400 times by 50 power minus 3 plus by 8.154 power minus 3. So it's equal to 23.2616. Right? So now everything is in already. Okay, so if we look at over here, okay, we found our neutral axis, this distance, to be equal to 8.154. Right? So both point A and point B, due to bending moment, right? Stress X will be what? Will be tensile, right? Because it's above the neutral axis. Below it will be what? Below below the centroid will be compression. Okay. Remember, this centroid, right? When we find the centroid, is based on what? It's based on geometry. Can you see that? This is centroid. Okay, it's all geometry based. Okay. So now once we have here, I'm going to find point A and point D. Okay. So stress X at point A, right? So this will be equal to the load, which is equal to 400, right? And it's going to be tensile, positive. Divide by the area is 104 times 10 to the power minus 6, right? And we know that stress as due to bending is under what? Tensile, right? So the MZ is equal to 23.261, 23.2616. The Y is 8.154. And the IZZ is equal to 3.88. Okay, so 400 divided by 104 power minus 6 is equal to 3.846 times 10 to the power 6 plus by 26.2616 times 8.154 power minus 3 divided by 3.88 power minus 9. So it's equal to 56. Wait. 26. Wait. Oh, 23. 23.2. That's the problem of using writing pad. No, it's the user, okay? It's nothing to do with the technology. So it's equal to 3.885 times 10 to the power 6. So 3.846 plus by 48.855 is equal to 3.846 plus by 48.855 is equal to 52,701 times 10 to the power 6 Pascal. Okay. So stress X in B. So it's still the axial load is still 3.846 times 10 to the power 6. Now the bending moment is going to be what? Compression, yes or no? That's why I tell you don't worry about positive, negative. Once you analyze this, right? Once you analyze this, the sign just come in. Okay. If you're gonna apply vector form, okay, good luck. You are trusting everything is in a black box. Okay. So at point B, the distance is equal. We calculated the distance earlier. Is from the bottom 11.854. And then divide by 3.88. Let me check. 11.85846. 11. No, where is 11.846? 11.846. 11.846. Come on. Okay. So this will be equal to 3.846 times 10 to the power 6 minus. So it's equal to 71.02. So 3.846 power 6 minus by 71.02 power 6. So this will be equal to 67.174. Okay. All right. So the next thing we will do, we're going to find the position. Excuse me. We're going to find the position of the neutral axis. Okay. We're going to find the position. So I think I need this. I need this data over here. I need this data over here to find.
Eugene,
Yes.
were we supposed to find the stress at point D instead of B?
Yeah, right. I wrote wrongly. Thank you. 1 pine. Okay.
Oh, I'm just reading out the chat there.
Oh, okay. Oh, Sean, you're right. 2 pines. One for Sean, one from Jenna. Okay, so I need this value over here. Okay. All right. Okay, I need this. You don't need to copy this. I just need those values. Okay. So this is my P06. Okay, so now we're going to sketch. Okay. Okay. Before so let's see what the question want us to do. Okay, so the question want us to find the position of the neutral axis. Okay, so the formula to apply, so neutral axis is where we have stress X is equal to what? 0. Okay, so we're going to apply this formula. Px is equal to stress X is equal to Px over A, right? And then the root formula says that this must be equal to minus mz over izz divided by y. Okay, that is the formula. So that's where I'm very careful of using. This is the valid formula. The moment has to be minus. Okay, so I'm very careful. If let's say you forget, it's like, oh, I cannot remember positive or negative. But I'm going to show you this technique. Then I'm going to show you a much simpler technique, a slightly longer steps. Even students that got that just even your niece or nephew or your brothers and sisters that completed high school can even do it. Okay, so let's say we know this formula. Okay, we memorize it. Okay, we know it. Okay, So to find the position of the neutral axis, we know that stress S equal to 0. Okay, so I'm going to call this equation number. So equation number 1, this will be equal to 0 px over a minus by mz over izz multiplied by y. Okay. So over here, you will have mz over izz multiplied by y is equal to px over a, right? So y is equal to px over a izz over mz. Okay. So now we are going to plug everything in. Okay, we're going to plug everything. So px is equal to what? 400. Or px over a, we know the value. Px over a is equal to 3.846. Izz is equal to 3.88 minus 9. And mz, we know that it's equal to what? Mz, I forget the number. 23.261. So the answer is equal to 3.846 power 6 times by 3.88 power minus 9 divided by 23.2616 is equal to 0.62. Okay, 0.642 times 10 to power minus 3 meters. So we only know that there will be a shift. Okay, there'll be a shift, right? So next one, I will show you another method, and it's so easy. As I said, okay, those of you that have niece and nephew in high school, or cousins or siblings in high school, they already can solve this problem. Okay, so it's just by pure geometry. Let's say you forget, okay, or there's a blackout, there's no internet. Your boss say, I want to know the position of the neutral axis, and your textbook has been downloaded illegally, given by the professor, which is me. That's so bad. Right. So what you do is you do this graphically. Okay. So the stresses is what? From 67, right? So I'm going to draw minus 80, minus 60, minus 40, minus 20, 0. Okay. So I need to, okay. So this is 20, 40. The tensile is what? Okay, I can start 60. So this is your stress X. Okay. Then you draw your Y. Okay. So this is my Y. So this is 2. This is 2, 4, 6, 8, 10. Okay. I don't need 10, but yeah, I need to. So this is your Y. So minus 2, minus 4, minus 6, minus 8, and minus 10. Okay. You can plot this on Excel, okay, and it will give you the y-intercept. Okay. So we know that 8.154, our stress is what? 52. Okay, it's 52.709. So 50 so 8.104, 52. I'm just eyeballing this, okay? So this is equal to 52.701, 8.154. Okay, 8.154. And this is 1 point. And then the other point is what? The other point is at 67. The other point is 67.174. 67. Okay, again, eyeballing. I need longer. I need minus 12 already down here. Right, we need a 12. So this is 60. So it's 11.1 11.8, 11.8. So it's somewhere around here, 11.8, and then the 67.174. So 11.8, 60. Again, eyeballing this 70, 67. So this